draft, and you all have the corrected version of it, I think, on the blackboard. But let me read through here. Here's the nasty word. Sometimes atoms can share more than 8. Now let's analyze here. Rule 1, 2, and 3, always, 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 and rule 1, 2, and 3, they violate on the low side of 8. 2, 4, 6. Okay, this rule we can violate on the high side of 8, sometimes. When, now it's going to be an atom, it's got to be a central atom, okay? We don't care about the outside guys. Can have more than 8 when they're a central atom. Common atoms that do this are sulfur and phosphorus and the heavier halogens and some of the noble gases. But there is an easier way. If I come up here to the periodic table, okay, here's some that I listed. The common ones, phosphorus, sulfur, and then I say heavier halogens, which means chlorine on down. There's actually a wonderful block here of 16 that can do it. And it's 4 across and 4 down. So you might want on your periodic table that you're drawing pictures on, that you might just circle this block of 16, and those are the guys that can, under certain circumstances, violate and have more than 8. But the most common ones you see, here, here, here. But I've noticed on my test bank, sometimes they like to slip in arsenic. Well, if phosphorus can do it, arsenic can certainly do it. But it's got to be these heavier ones. It's not going to be the guys in the first or second period there.
Are you including the silicon row?
No, I'm not. It's just phosphorus and over, and phosphorus and down.
So wait, are you
Let me
including?
circle again. 4 across. 1, 2, 3, 4 across.
So including the noble gases?
Yes, including the noble gases. Now normally, we don't think of the noble gases as ever reacting. But in the late 1950s, early 1960s, out at Stanford, I believe it was, or Berkeley, if you use really harsh conditions, they will react, really high pressure and high temperature, you can force them to do it. Anything is possible in chemistry if you're willing to pay the price.
You have silicon in the notes, that's what she asked.
Yeah.
Do I?
It is in the notes.
Oh, is it in the notes?
It's not on
It says in ours.
Okay.
It says, yeah, silicon, phosphorus,
Okay.
sulfur,
Normally,
chloride,
okay.
plus xenon.
Okay, perhaps this one should be in there, but I usually think of this block of 16, okay? If silicon should come up, I'll put a little notation, it can violate on the problem, okay? That will solve that issue. It's not a common one to do it at all. Okay, so I just think of it as a block of 16 there. Now, how are we going to deal with this? We're going to have to deal with it a little bit differently. And here's the first one we're going to take. Okay, first of all, name that thing for me. We can never forget nomenclature.
Phosphorus.
Yeah, phosphorus pentafluoride. And why did you get to say penta?
Because they're both
non-metals.
2 nonmetals. Okay, phosphorus pentafluoride. Very good. Now, when I look at this, there's 2 things that I notice right off. Phosphorus is in the middle. High alert. It might violate. However, here's the thinking part. If this is 5 fluorines that we know are going to be bonded to the phosphorus,
Has to be 10.
we're going to share at least 10, aren't we? Okay, so I've got to write a note, and this is how I would deal with these guys for Rule 4. I'll take a look at this, and just as Brittany said, share at least 10. Everybody catch that? Because if you got 5 bonds, 5 single bonds, you are sharing 10. Now, let me just come over here. Maybe a picture would be better than that. I've got to share with 5 of those fluorines. Make a wagon wheel here. Because there's 5 of them out there, I know I've got 5 bonds. And on these guys that violate on the high side, we are never gonna worry about multiple bonds here. Okay, you're just gonna have singles. So we know it's gonna end up looking something like this, but let's go back through. And here is what I recommend. This is how I attack it. We have this flash of insight, and I write myself a note. Share at least 10. Okay, then I go through here, just act stupid, act like you never heard that rule 4 at all. And we're just going to carry through here like we don't know phosphorus might violate. So here, need. Let's just pretend we didn't catch this. And so I'm going to say phosphorus needs 8. And I have fluorines. Each fluorine needs how many here? Nikki in the back. Each fluorine needs how many? Think music. When your back's against the wall, what's the magic number? Help her out, Liz. 8. The octet rule is in place for most of these. So let's see. We've got what here? 48. Okay, so right now we got a need of 48. Notice I didn't take into account anything about the phosphorus. We got to act dumb at this point. Let's think available. Okay, a phosphorus comes with how many, Aaron? Phosphorus? 5. I think you were answering the next question. So each fluorine comes with how many, Aaron? 7. So there's 40. Now this would tell us to share how many? 8. Okay, at this point we get a lot smarter. Here's how I do this. I've got my note to myself, and I have this 8 down here. The bigger number always wins. I don't care if that bigger number shows up here, or that bigger number shows up here. That means that is trash. That means that is also trash. And this is how you handle Rule 4 only. You have a flash of insight. You got to share at least 10. But then you go through here like you don't even think about that. It comes out 8, you go 10 wins. Okay? Available, though, is always good. Remember, a letter, if you get the grade of A in here, you're not going to dispute that. An A is always good. Here, the A is always good. You never trash it. But if this and this are different, you trash N and you trash S. Okay, so we're going to share 10, which is what I've already done right here. Now, on each fluorine, since each fluorine is in the same situation, how many more pairs? Tran, how many more pairs do I need on each fluorine? It has access to 2 electrons right now, so how many more electrons or how many more pairs of electrons? You can answer it either way. 3 pairs. Because fluorine needs 8. It has 2 already, so it needs 6 more electrons or 3 more pairs. Tran, are you okay on that? You don't look like a believer. Let's take it from the top. Let's look at this fluorine. Okay, look at this fluorine with me. This fluorine feels like it has 2. But fluorine never violates the octet rule for us. It needs 8. So if it's got 2 already, 3 more pairs or 6 more electrons. Okay? And that's going to be true of each one of those. Okay, now at this point we check a work. Did we share 10, the winner? Yeah, we did fine. This is critical, so critical. Did we use 40? So you come over here. Let me take a shortcut, and if you don't see the shortcut, I'll go back and go 2, 4, 6, 8. I'm going to cover this guy up. Every one of these guys has 8, and I got 5 of them, so 5 times 8, that's 40. Check. We are in good shape, really good shape. Okay, and does everybody have an octet that needs it? Yeah. the fluorines all have their octet, and here we see phosphorus has violated the octet rule by having more than 8. Okay, questions? Anything I could answer?
Why did you cross through the first equation, the end?
Okay, because this need, if this is wrong, this need is wrong because that 8 is wrong. It should have been a 10, but we're not going to go back and revisit it because when I see this is the winner, I'm going to trash those two things.